Our fourth and final speaker today is Dr. Carlos Casiano. He is Professor of Microbiology, Molecular Genetics and Medicine at Loma Linda University School of Medicine. And he's going to give us an overview of the current scientific and medical understanding of the COVID-19 pandemic, the effectiveness and limitations of COVID vaccines, and I believe a brief summary of the literature on alternative treatments. So, Dr. Casiano, you're welcome, and the time is yours.
Thank you very much for this invitation. I'm glad to be here. It's a pleasure to share some of the knowledge that we have on the current pandemic. And greetings from Loma Linda University. I'm in my office in this building right now. I'm just beginning to see the sun out. So it's really nice to be with you today. These are the topics that I intend to discuss briefly within the next half hour. The current state of the COVID pandemic. I'll talk a little bit about coronaviruses. The concept of natural immunity. When we talk about natural immunity, what are we really talking about? The modulation of the immune system by the SARS-CoV-2 virus, COVID vaccines, how do they work? How effective, how safe they are? And I would like to also touch on alternative COVID medications. This is where we are now in the COVID pandemic. These are the data from Johns Hopkins University as of yesterday. So we have lost about 5.5 million people around the world to this pandemic. And these are numbers of people who have died, and it has been documented that they died from COVID. In the end, the numbers are going to be much higher once we have an idea how much excess death we had in the different countries. And this is a pandemic that doesn't go away. This pandemic started about 2 years ago. We're going into the third year. And now the pandemic is affecting strongly, not only here in the United States, but also in Europe, South America, many different continents due to the rise of the Omicron variant. And we'll talk a little bit about this variant and why this variant is causing so many cases and hospitalizations. This is a picture of COVID-19 in Europe as of yesterday. The country with the highest number of cases is the UK, with about 15 million cases, followed by France, Russia, Italy, and different countries. In terms of deaths, the country with the largest number of deaths so far is Russia, with over 300,000 deaths. Now, if you look at the overall death, and this is the number of deaths per cases, the overall deaths fluctuates between 1 to 3% depending on the country. Right now in Europe, the country that has the lower overall death rate is the Netherlands with 0.5. That means 1 in every 200. The UK has an overall death of 1, that's 1 in 100, whereas Romania has an overall death of 3, which is 3%, 3 in 100. To look at it this way, let's suppose that you go to a church that has 1,000 members and all the members get sick because of Omicron and Delta and the other variants. That means that the overall rate of death in that church is going to be about 20. So that church will lose about 20 members with an overall rate of about 2%, which seems to be the average around the world. But we have to take these numbers in the context of age. Because if you look at the overall death per age, what you see is that people that are 80 years old and above, their overall percent death is about close to 15%, followed by 8% in people that are 70 to 79 years old. And then it goes down as the people are younger. But it doesn't mean that children don't die of COVID. It says 0% here because it's less than 1%, but we're gonna see the numbers in a while. Yes, children can die of COVID. Now, these are the deaths that have been documented. There is another number that eventually we're gonna have to pay attention to, and that's excess death. This is the number of deaths that have occurred in excess during the pandemic compared to previous years. And for example, in Bulgaria, we have about 31,000 confirmed COVID deaths, but excess death compared to previous years is double that amount. It's about 61,000. Same in Russia, 3 times more. Same in Serbia, 4 times more. So in the end, we're going to see that the excess death related to COVID, whether it was direct death induced by COVID or indirect, is going to be much higher. So the effects of this pandemic in terms of deaths are going to be seen more clearly in years to come. Now, COVID-19 is the 3rd most deadly pandemic of the past 100 years, the Spanish flu that happened between 1918 and 1920. It killed between 20 to 50 million people around the world. The HIV/AIDS pandemic, which started in 1981 and is still going, has killed between 32 to 36 million people in about 50 years already. Then the COVID pandemic, which started 2 years ago, it has killed already about 5.5 million and growing. And as I said before, because of the excess death, we don't know what's going to be the final toll when this pandemic is under control. Then we have other minor pandemics, and minor in the sense that they didn't kill as many as the top 3, as the Asian flu of late 1950s, the Hong Kong flu of 1968 and 70 that killed between 1 to 2 million, and the swine flu that started about 12 years ago that has killed about 200,000. Now, the common denominator for these deadly pandemics is that they're being caused by viruses that mutate rapidly and evade the immune system, and it's very hard to produce effective vaccines against these viruses because they change so much that a vaccine today against a particular strain can work really well, but then the strain of the virus or the variant that comes 6 months later or a year later may not be neutralized effectively by the vaccine. And I'll discuss this in more detail later. Now let's talk a little bit about coronaviruses and coronaviruses. There are many different types. Every time we get a cold during the winter, it's very likely that that cold is caused by a seasonal coronavirus. There are 4 different types that cause the common cold. And typically these are, these viruses produce mild disease, rarely require hospitalization. Then we have the SARS-CoV-1, the severe acute respiratory syndrome disease caused by coronavirus 1. And that happened in 2003. About 10,000 people got infected around the world with a fatality rate of 10%. Then we had the Middle East respiratory syndrome, the MERS-CoV, caused also by coronavirus, and that happened in 2012 with a few thousand people that perished. And now we have the SARS-CoV-2 coronavirus, which is causing COVID-19. A particular feature of all coronaviruses is that they have these spikes in the surface of the virus. And the spikes are necessary for the virus to attach to the cells in our body and then penetrate inside the cells so that the virus can reproduce inside the cells. The flu virus is similar, but it's a totally different virus. Flu and COVID are two completely different viruses. And how do we know that? Because we have the ability to isolate these viruses and study them at the molecular level in the labs and distinguish between a coronavirus, a flu virus, an HIV virus. That can be done in the labs, and we can study those viruses all the way to the molecular level. So it is relatively easy to isolate these viruses, purify them, and study them in the lab. So the flu virus has a structure similar to spikes, but it's a very different virus. Now, the SARS-CoV-2 virus, especially the Omicron variant, is highly transmissible. And the N95 and KN95 masks, those are the ones that provide the best protection. So you have an infected asymptomatic individual here that when talking is basically expelling droplets. And these droplets of saliva contain virus. So these droplets of air contain virus particles in them. So if this person is in close contact with two healthy people, one of them wearing a mask and one not wearing a mask, very likely that the person that is not wearing a mask will get infected because of the viral load that is going to penetrate through the nose of this person. Whereas the person that is wearing the mask is still going to have a risk, but it's going to be a minimal risk. Now, if the person that is talking is wearing a mask, then the amount of droplets that are going to be expelled is much lower. So there is minimum exposure for the person that is wearing a mask, but the person that is not wearing a mask may still get infected. The best mask right now, particularly to protect against Omicron, which is the most transmissible variant of the COVID virus, are the N95 mask or the KN95 mask, followed by the surgical mask, followed by the homemade masks, which are not that protective because they don't have filters. These two have filters that prevent the virus to come into our nose at very high quantities. Now, some people believe that by wearing N95 or KN95 masks, they're going to be breathing their own CO2. And this is not correct because our CO2 that we expel goes through this filter. These filters, the pores are not big enough to retain the CO2 that we breathe or to prevent us from breathing oxygen. The air goes through the filter so we can breathe easily through them. What the filter does is that it traps viral particles. Any pathogens that we expel through our mouth, through our nose, gets trapped in those filters, therefore prevents us from infecting other people, but it's not gonna suffocate us, it's not gonna prevent us from breathing, or is not going to cause that we breathe our own CO2. Now, these variants result from too many infections and from a virus that mutates rapidly. Since the original virus discovered in Wuhan, we had 5 different variants: the alpha, the beta, the gamma, the delta variant. This delta variant has been the most lethal so far. And then recently we got the Omicron, the most transmissible. so far. Why so many variants? The reason is that this virus mutates very fast. Typically, viruses have the capacity when they are reproducing, when they're replicating their genetic material, they have the capacity of correcting random errors that happen during that replication. They have what is called a proofreading transcriptional mechanism where the virus corrects those errors. But there are certain viruses like the HIV virus, like the COVID virus, that do not have a very efficient proofreading mechanism. So when these mutations happen, the virus may not correct them, and then you have variants that come from those mutations. For those mutations to occur, we need to have individuals that are infected, that their immune system is not clearing those viruses because either they may be immunodeficient or they are not vaccinated, and the virus has sufficient time, sufficient bodies to replicate, cause these errors, engage in these mutations, and then the virus produce different variants. So the more unvaccinated people we have that are infected, the more immunocompromised people that are unvaccinated and are infected, the more variants of the virus are going to be continue generating. And let me say that Omicron is not going to be the last one. There are already some variants of interest that have been identified around the world. We don't know when we're going to get the next variant. Now, a silver lining so far is that the Omicron is not as lethal as Delta, highly transmissible, but not as lethal. However, because it's highly transmissible and is causing so many people to get sick, the number of hospitalizations are very high, and this is overwhelming hospital systems. So the people who have severe disease or people who have other conditions that need medical attention are having problems finding beds in hospitals. Now, the worst case scenario is that we get a variant that is as lethal as the Delta or more lethal than the Delta, and as transmissible as Omicron or more transmissible as Omicron. That would be the worst case scenario, where we have a high lethality, high transmissible virus, and it may happen. It may happen as long as this virus continues finding bodies, unvaccinated bodies, immunocompromised bodies, where this virus can continue replicating without being neutralized. Now, what happens inside our bodies when we get infected with the COVID virus? So the virus approaches our cells, and the virus has a spike protein. This spike protein binds to a receptor that is present in the surface of our epithelial cells. There are two of those receptors. They're called the ACE2 receptor and the TMPRSS2 receptor. They're regulated by androgen hormones. And I'll talk a little bit about how men who have elevated levels of testosterone because of genetic predisposition have elevated levels of these receptors and may be at a higher risk of getting a more severe infection. So the virus uses the spikes to penetrate inside the cells. The vaccines that are currently being made, particularly the messenger RNA vaccines or the protein vaccine by Novavax, this vaccine is designed to induce our immune system to generate antibodies that neutralize these spike proteins and prevent the virus from binding to the ACE2 or TMPR receptor. But once the virus attaches to the cell, the virus is going to release the RNA in the cell. The cell is going to start producing that RNA that's going to lead to viral particles to form inside the cell. So the virus is going to reproduce inside the cell. The virus is going to exit the cell, spread through the body, causing damage to different organs. And during this process of replication, the virus may change because of these spontaneous mutations that happen predominantly in the spike protein. So the more human bodies that are available to infect, the higher the chances of new variants being generated. So when we get infected, let's say that we get infected with a foreign infectious agent, what happens inside our body? Let's say that we go into our backyard, we are not using shoes, we're barefoot, and to our bad luck, we get stuck with a nail in the foot. Now you're gonna have this bacteria, some of them that produce a tetanus toxin, they're gonna penetrate our body. And what is going to happen is that we have some cells in the immune system called dendritic cells, which are going to capture those bacteria, are going to take them to the lymph nodes. And then in the lymph nodes, the immune system is going to mount an attack to those bacteria. However, because they're producing a very potent toxin, we may develop tetanus, which could be fatal, or it could cause a really bad infection. So we need a vaccine. We need a tetanus vaccine to prevent that from happening. And there are several different tetanus vaccines that have been used for different people. So the vaccine is not preventing the infection. The vaccine doesn't prevent the bacteria to come into our body. The vaccine prevents the severe disease that infectious agent produces. And this is a concept that we need to understand. Vaccines do not prevent the infectious agents to invade our body. What the vaccines prevent is the severe disease caused by that infectious agent. So vaccines are known to prevent polio disease, rabies, smallpox, measles, tetanus, whooping cough, but they don't prevent those microorganisms, those bacteria or viruses from coming inside our body. They prevent the disease caused by those infectious agents. Now let's talk about natural immunity. What are we talking about when we talk about natural immunity? There are two components of immunity. Our immune system is composed of two complementary components. One is called the innate immunity. That's the immunity you're born with. The other component is the adaptive immunity. That's the immunity that you acquire through either infection or immunization. And people believe that natural immunity is only the one that you're born with. No, natural immunity is that immunity that is generated against any infectious agent, whether it's innate or whether it's adaptive. So the innate immunity involves barriers that keep the viruses from entering the body. And these are surface and internal defenses. And some of those barriers are here present in our nose, in our respiratory tract, that prevent those viruses from coming inside the body. So components of the innate immunity include the surface defenses like the skin, the hair, mucus. Internal defenses, there are different types of immune cells like mast cells, natural killer cells, phagocytes, and those cells prevent those viruses and bacteria from going inside the body. They typically stay in the upper respiratory syndrome. One of the molecules that is produced as part of the innate immune system are the interferons. And when the interferons do, they detect the presence of a virus, they are produced, they activate some of these cells, and the idea is to prevent the virus from further spreading. But then let's suppose that the virus, in this particular case, the COVID virus, evades that innate immunity, and it does happen. This COVID virus has the ability to evade innate immune defenses. That has been well documented in the scientific literature. So when that happens, then our acquired immunity kicks in. And the acquired immunity involves the activation of T cells, which are the master regulators of the immune system, and B cells, which are the ones that produce antibodies. T cells attack infected cells. T cells activate B cells, and the B cells produce the antibodies that are going to neutralize the virus. So we need these two components. Adaptive immunity is typically activated when we get infected with the virus, and the virus overcomes the innate defenses, go inside the body, then adaptive immunity starts immediately activating T cells and B cells to neutralize that virus. Immunization with vaccine also activate the adaptive response. The idea is to activate these T cells and B cells as soon as possible to prevent the virus from causing lethal damage to our bodies. So here we have vaccine or infection, activate the T cells activate B cells, T cells activate dendritic and phagocytic cells, which uptake the virus. And during this process, the immune system produces what is called inflammatory cytokines. Without those inflammatory cytokines, we cannot have a proper immune response. The problem is that this virus hyperactivates the immune system, leading to excessive production of inflammatory cytokines, leading to what is called a cytokine storm. And that cytokine storm damages a lot of our organs, leading to death in individuals with severe disease. So as I said previously, the COVID virus is very notorious to evade innate immunity and may cause moderate to severe disease. So the interferons, which are one of the first lines of defense against the virus, this response may be blunted in some individuals because of genetic predisposition, because of hereditary factors, or because the virus itself blunts the interferon response. Also, the virus, through the spike, may have a very high affinity binding to the receptors. And the more receptors we have, the better the virus may bind. And the Omicron variant and the Delta variant has different affinities for this receptor. So some individuals express high levels of this receptor because of genetic predisposition. It has nothing to do with lifestyle. It's because of genetic predisposition. And then some individuals produce excessive amounts of inflammatory cytokines. Individuals with conditions such as diabetes, such as other obesity, tend to produce higher levels of these inflammatory cytokines, and those cytokines may cause that severe disease. So the COVID virus not only evades innate natural immunity, it also evades adaptive or acquired immunity, causing moderate to severe disease. And this is an illustration that I give to my medical students when I teach immunology to them. You know, in my hometown, Maya West, Puerto Rico, we like tourists and we like to translate signs for our tourists. And this is a sign that translates the Spanish word for hotels, hoteles, and then the translation is hotels. And you may laugh, you may say that in our hometown, we go the extra mile because we translate a word that doesn't need translation. And this is true, but this is who we are. Now, let's suppose that these words represent proteins and that each letter is an amino acid in a protein. So Here we have the H that codes for the amino acid histidine. The O, we don't have an amino acid that starts with O, but let's convert that O to a Q. That's glutamine, T is threonine, E is glutamic acid, L is leucine, E is glutamic acid, S is serine. So they look very similar, but wait a second. There is an extra E here. There is an extra glutamic acid. The adaptive immune system, the acquired immune system, is so specific in the immune responses that just a change in amino acid may lead the immune system to recognize that protein as totally different from this one. That's the level of specificity. And that's precisely what the COVID virus does. The COVID virus changes, mutates. So look at the wild type virus. This is the representation of the structure of the virus, and this is the receptor binding domain. This is the domain of the virus that binds to the ACE receptor. These letters and numbers here represent the different mutations that occur in the Delta variant. And there are a couple of mutations in the receptor binding domain. Now look at the Omicron variant. Look at how so many different mutations happen there. If you look at the molecular structure, the wild type, the Wuhan virus, this is how it looks. And the Delta, each red or blue dot means a different mutation. Look at the Omicron, so many different mutations. And what this does to the immune system is that now the immune system is gonna recognize the Omicron as slightly different from the Delta, which was recognized as slightly different from the wild type. So that's why people get reinfected with the virus. That's why people who are vaccinated against the wild type or the Delta now are getting infected with Omicron, because the immune system now is seeing what it looks like a completely different virus. The good thing is that the vaccines that we have so far that work against the wild type and work against the Delta, they still induce neutralizing antibodies that can protect against severe disease caused by Omicron. The vaccines cannot protect against Omicron infection, but can protect against severe disease caused by Omicron. Now, we need to keep in mind that adaptive immunity is influenced by age. So the more we age, we're gonna have B cells being depleted, less B cells. We have T cells that the repertoire is skewed or is even depleted. And the CD4 T cells, these are the ones that control all the immune responses. They, as we age, they differentiate into what we call Th17 T cells. Those are inflammatory T cells. You don't want to have many of those T cells in your body. But as we age, naturally, we see these changes. That's why our immune system becomes weaker and weaker as we age, regardless of whether we have a healthy lifestyle. The healthier the lifestyle we have, the more protection we're gonna have as we age, but aging still impacts the immune system. As when we are young, we have a very good thymus that produce T cells. We got good bone marrows that produce B cells. We have good lymph nodes that fight infection. But as we age, all those weaken. Then we start developing inflammation in our lungs and in other organs that can be damaged by the COVID virus. Now, let's look at age and COVID deaths. And this is the latest data from this week from the Centers for Disease Control. These are the number of people who have died in the United States because of COVID. Children can die of COVID. 710 children have died of COVID in the United States. That's a percentage of 0.08, and I'm sorry that my mouse is extremely sensitive. 0.08% of children have died of COVID. And you would say, oh, that's a very small amount. It's a very low percentage, but 700 children who have died of COVID, that's too much. 5,000 young people, 2.4% of the total, can also die of COVID, but they do have lower risk. 22% of this amount of COVID deaths were among the middle-aged people. Now, the great majority of the deaths from COVID, 70%, are among people over 65 years old. So age is an important risk factor, but children and young, healthy people can also die of COVID. Severe COVID is going to damage all our internal organs. It can damage the lungs, the liver, the kidneys, the intestine, the brain, the eyes, the nose, causing this organ failure that we see in patients with severe disease. And this organ failure is mostly due to this hyperinflammation syndrome, this cytokine storm that our immune system, when it's hyperactivated, produces, leading to organ damage. Now, these are some of the risk factors for severe COVID. As I said, older age, lung conditions such as asthma, pulmonary disease, lung cancer, pulmonary fibrosis, heart disease, some brain conditions, diabetes and obesity because of the elevated levels of inflammation inside the body, cancer. Patients with cancer receive immunosuppressive therapies that weaken the immune system. There are other patients that don't have cancer, but have weakened immune system. For example, patients with autoimmune disease that are receiving immunosuppressive therapy, their immune system is weakened. Patients with chronic kidney and liver disease. People with androgenetic alopecia, men with androgenetic alopecia, and this is testosterone-driven hair loss early in life in their 20s. Or women that have polycystic ovarian syndrome, they are at a higher risk of developing severe disease because of the elevated levels of testosterone in their bodies. And this is hereditary. This has nothing to do with our lifestyle, it's hereditary. So some of these conditions are lifestyle related, but some other conditions are related to genetic predisposition, inadequate interferon responses, mutations. So that's why we need to maintain a very healthy lifestyle, but keeping in mind that our genetic predisposition may predispose us to develop severe COVID disease. Now, COVID may kill us. We know that. But let's suppose that we survive, whether it's moderate to severe disease. We may still suffer from a disease called long COVID that is associated with acute respiratory distress, pulmonary deficiency, chronic fatigue, autoimmune conditions, brain fog, vascular disease, thrombosis, heart problems, sleep problems, headaches, dizziness, mood changes, and abortion. This is abortion induced by the virus. We're not talking about abortion induced by vaccines, and we're going to mention that in a few moments. Now, the data so far, and this is a study that came out recently, indicate that 43% of survivors of COVID suffer from long COVID. 57% of people who were hospitalized suffer from long COVID. And the effects appear to be higher among women compared to men. Now, what are the vaccines that we have available so far? What are the vaccine types? Well, we have vaccines that use viral vectors. This is a vector derived from a virus that doesn't replicate, doesn't infect, and that vector contains the genetic material for the virus that is being used to generate an immune response. The Johnson & Johnson vaccine is based on this viral vector. This type of vaccine has been used for Ebola viruses. Then we have the RNA vaccines. These are the Moderna and Pfizer vaccines. We have the protein subunit vaccines that have been used in the past for hepatitis B, papilloma, shingles. Novavax vaccine is using this particular platform. Then we have the live attenuated whole virus vaccine that has been used for measles, smallpox, yellow fever, and the inactivated virus vaccine. The Chinese vaccines use inactivated viruses, and this type of vaccines have been used for flu, polio, rabies, hepatitis. So we have different types of vaccines. Now, the ones that people are a little bit more reluctant to use is the messenger RNA vaccine because of the perception that is a new technology that hasn't been proven. This technology started to be developed in the late 90s, early 2000s. Many scientists have worked in this technology. And this person, Caitlin Carrico from the BioNTech Pfizer company, together with another scientist, Drew Weissman, in 2005, after many years of working in this type of vaccines, in 2005, they make a key discovery that allowed this messenger RNA to be stabilized inside our body. And that was a seminal discovery that led to the mass production of these vaccines. So these vaccines are not new. They have been developed for at least 20 years already. What this messenger RNA does is that when it's injected in our muscles, it goes inside our cells, doesn't go inside the nucleus, it doesn't get incorporated into the DNA, stays in the cytoplasm of the cells, is picked up by ribosomes. The ribosomes make proteins out of this messenger RNA, and those proteins encode the spike proteins. Those spike proteins are secreted into the body, and then our immune system makes antibodies to them to neutralize. The spike proteins by themselves do not infect the body. What infects the body is the virus that has spike proteins, but the purified spike protein doesn't do anything to the body. That's why the vaccines are designed for our immune system to mount an attack to the spike protein. How effective are these vaccines? Before the Omicron, the data that we had for the Delta was that the vaccines were highly effective, preventing up to 90 to 95% of hospitalizations and severe death. And there have been plenty of studies in different states in the United States. There was a United States study with 41,000 patients published in the New England Journal of Medicine, where the effectiveness was calculated at about 90%. Another study in the UK with very similar results. Another study made by the Centers for Disease Control with very similar results, about 90% protection against severe infection and hospitalization. But then Omicron came. And Omicron is now infecting people who has been vaccinated. Why is that? Because it's a new variant that the immune system is beginning to see as something related to what it saw before, but not exactly what it saw before. So it's kind of a new virus for the immune system. So now the immune system has to be retrained to make antibodies against Omicron. The good thing, as I said previously, is that the vaccines that were already developed, especially with the booster, they still induced neutralizing antibodies to Omicron. If you look at the latest data, and this data is from January 12th, from a week ago, this is where we are in terms of hospitalization. This is the graph for unvaccinated people in New York who are hospitalized. And this is the graph for those who are fully vaccinated. Fully vaccinated means first, second dose, and the booster. So the number of hospitalizations is very, very low for the vaccinated extremely high for the unvaccinated. Yes, the fully vaccinated people are still getting infected, but they're not getting hospitalized at levels as high as the unvaccinated, which presents evidence that the vaccines are working. Now, if these vaccines are effective, then why do we need boosters? Well, this is how the immune system works. So we got the primary and secondary vaccination. We got this immune response very high. But as time goes by, the immune response wanes. We've got less antibodies being produced, although we have T cells that are long-term. And those T cells stay in our body as memory and can protect in the future against severe disease. So we need a booster to keep the levels of antibody high in case another strain comes. And that's precisely what happened. When the boosters were introduced, right after the boosters came Omicron, and now the boosters are proving to be effective against Omicron-induced severe disease. So the vaccines, again, are not designed to prevent the infection. The vaccines are designed to prevent severe disease and hospitalization. Yes, there are people that are fully vaccinated that are being hospitalized and are dying at very low rates compared to the unvaccinated. And typically those people are either immunocompromised, they're cancer patients, or patients that have blunted immune responses because of the immunocompromised system. Boosters are not new. You know, we need annual boosters for the flu virus. Why? Because this virus changes so much that every year we have a whole new variant, so we need boosters. Well, how about the coronavirus? Are we going to need annual boosters? We don't know. Most likely, yes. Maybe every 6 months, maybe once a year, maybe every other year. But how about other viruses like the measles? Yes, we need 2 boosters for that. The polio, we need 4 for that. And those are long-lasting responses because the measles virus and the polio virus, they're highly transmissible, but they don't mutate. They don't change a lot as compared to the coronavirus. Now, what are the effects of vaccine versus the effects of the COVID infection? The COVID infection, as I mentioned, can damage a lot of organs, leading to long-term effects. Deaths from COVID infection, about 2%, but higher in the elderly. How about the COVID vaccine? Well, almost everyone who gets the vaccine has drowsiness, chills, pain at the injection site, headache, muscle pain, nausea. Those are what I call a mild adverse effect. How about the major effects? Let me try to get here. Anaphylaxis, allergic reaction, about 3 to 5 per million. Thrombotic events, that's more with the Janssen vaccine, 1 per million in people over 65, 1 per 20,000 to 60,000 people under 55. Guillain-Barré syndrome, that's a neurological syndrome, 20 per million with the Janssen vaccine. Myocarditis or pericarditis, 20 to 40 per million with the Pfizer Moderna vaccine. So the serious side effects of the vaccines tend to be relatively low. But the serious side effects of the infection, as I said before, 50% of people experience them long-term. The vaccine has been proven to be safe for pregnant women. This is a very recent study that basically concluded that in retrospective cohort of 40,000 pregnant women, the COVID vaccination during pregnancy was not associated with preterm birth or small gestational age at birth overall. How about children? The latest study. The study does indicate that the vaccines are safe for children. However, it does mention that children tend to have side effects on the vaccine, but those tend to be relatively mild. But it tells parents that they need to look for those side effects, including pain, fever, chills, but they tend to resolve within days. Now, people talk about the ingredients of the COVID vaccines. We know the ingredients. They are published in the website of the CDC for all the vaccines. We have messenger RNA, we have lipids, nanoparticles, and later in the discussion session, we can talk about that. Traces of cholesterol, acetic acid, stabilizers of pH, like trometamine, in traces, sugar, salts. This is what it is in the vaccines. We know that because it's published. The vaccines do not contain tracking microchips. They do not contain magnets. They do not contain foreign DNA that can alter ours. They do not contain live virus, microparticles, heavy metals, carcinogens, graphene oxide, eggs or animal products, fetal tissues. Those are not in the vaccines. How do we know? Because the makers of the vaccines are under the obligation to report what is inside the vaccines to the Food and Drug Administration and to the CDC, and that information is publicly available. About COVID medications, other COVID medications, we have other medications, antivirals or anti-inflammatory like remdesivir, dexamethasone, Regeneron. Those are being used in the clinic right now. They are highly recommended. About vitamins and supplements, the science is still controversial about vitamins and supplements. However, there is a well-documented association between severe disease and low levels of vitamin D. Does that mean that low levels of vitamin D causes severe disease? No, it's just an association. It's not a cause, just an association. So if I were you, let's keep using vitamin D, let's keep our zinc levels high, let's keep our vitamin C and vitamin E high, let's keep our healthy lifestyle. However, those are not curative. They may prevent severe disease unless we are genetically predisposed to develop that severe disease. How about this other alternative medication, hydroxychloroquine, chloroquine, ivermectin? I would like to, and I'm almost done here, but I would like you to look at this recent study. Is the most comprehensive study that has been published just a few weeks ago by a Polish group. This group from Poland, they look at the whole scientific medical data on different drugs with therapeutic potential for COVID. They analyze every single study, and then they came to conclusions. And based on the different studies, they concluded that the literature, what is available based on results on clinical trials, insufficient data, toxicity, hydroxychloroquine, ivermectin, convalescent plasma, amantadine, niclosamide, Chinese herbal medicines are not recommended for the treatment of COVID, and there is little evidence that they prevent severe disease. I would like you to take a look at this study. You may find that via PubMed. This is a National Library of Medicine search engine for scientific literature. You can search there this particular study because it's very eye-opening and revealing. Loma Linda University supports COVID vaccination. We vaccinated about 100,000 people just by March 2021. Together, we can prevent COVID through vaccination, use of protective face masks, social distancing, washing our hands, a very healthy lifestyle. The Adventist lifestyle may help in the prevention. And I would like to invite all of you to continue the healing ministry of Jesus by taking the precautions that we need to take to prevent this fatal disease. Thank you very much, and I'll be willing to entertain the questions during the discussion session.
Thank you very much, Dr. Cassiano. It was very informative, and thank you for making it understandable for lay people too. I think that's really